You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Andrea Dupree. Dr. Andrea Dupree is a senior astrophysicist at the Smithsonian Astrophysical Observatory, which forms part of the Harvard Smithsonian Center for Astrophysics in Cambridge, Massachusetts. Dr. Dupree received a BA in astronomy from Wellesley College and a PhD in astronomy from Harvard University. Her research focuses on cool stars like the Sun and their planets to understand how they are born and how they evolve, with particular emphasis on the analysis of spectra. She and another member of the Kepler team, Ron Gilliland, obtained the first image of the surface of a star, Betelgeuse, using the Hubble Space Telescope. Dr. Dupree has published several hundred scientific papers and articles and edited several books. She is a past president of the American Astronomical Society and has served on and led many committees of the U.S. National Academy of Sciences, NASA, and others to determine the future course of astronomical research in the United States and other countries. She held the position of Associate Director at the Harvard Smithsonian Center for Astrophysics, the first woman and youngest person in the position, and served as head of the Solar, Stellar, and Planetary Sciences Division of the CFA.
Dr. Andrea Dupree, welcome to the program.
Well, thank you. I'm delighted to be here.
Now, Doctor, among many things, you study the giant star Betelgeuse in Orion that we all know and love from its red color. Well, not long ago, Betelgeuse started behaving a little bit oddly and very visibly dimmed. And no one really knew what was causing it, why it did that. But then again, Betelgeuse is a variable star and has been known to be such for a very long time. But this was sort of out of character even for Betelgeuse. And at the time, there were a bunch of hypotheses floating around of what might be happening here, including a run-up to a supernova. Are we closer to understanding exactly what caused that first dimming event with Betelgeuse?
Well, we think we have some strong indications from our Hubble observations about what went on. But I also must underscore that the constellation looked so unusual this January and February. I mean, this star, which we know and love, the bright red star in the shoulder of the Orion constellation just vanished. It got really dim, and the constellation just looked completely abnormal. But I think we have an idea of what's happening. And this comes from a program that I led on the Hubble Space Telescope. Now, Hubble is an amazing instrument because it's above the Earth's atmosphere, so it doesn't subject any of the data and the information to blurring and things like that. And it also has a very small field of view with its spectroscopes. Now, a spectroscope is an instrument that takes light from the star and breaks it up into colors. And from that light, we can tell what the star is made of. We can tell what the star is doing, what different layers of the star are doing. Are they moving in? Are they moving out? What's happening with the star? So, and the fact that Betelgeuse is close, that makes it also big. And the fact that we're also looking in the ultraviolet part of the spectrum, where Betelgeuse is even bigger than what we see with our naked eye or in the optical part of the spectrum, meant that with Hubble, we could actually look at the spectrum, look at the colors of the light from different parts of the star. We could move Hubble across the image of the star and find out what's happening in different parts of the star, whether the north was moving in or out, or whether the south was moving in or out. And what we found was very interesting. We've been looking at Betelgeuse starting at the beginning of 2019. And we observed it. We made a visit in January and another visit in March, and everything looked fine and normal and nothing surprising was present. But then when we got back to Betelgeuse in September, because you know that because the Earth moves, sometimes Betelgeuse gets very close to the sun and we're not able to see it from the Earth. But when September arrived, we could point at the Hubble telescope back at the star again. And what did we find? We found that in the southern part of the star, this is the southern quarter of the star, there was a huge, bright, hot mass of material that was just moving out. And we could tell this by looking at the shapes of the lines. We could measure the shapes. We could measure the velocity. And we could see that there is hot material. We could also see that it was very dense. It was much denser than the other material on either side, or in the north, or in the east, or in the west. So in the south, for September, October, and November, we saw this enormous cloud of dense, hot material moving out. Now, that gave us a clue, especially since at the end of December, we used an imager at the European Southern Observatory in Chile, and we were able to actually take a picture of Betelgeuse in the optical region, like in the light that you see normally and with your own eyes. And we found that the southern part of the star was faint. It was dim. It was as if there was something in front of the southern part of the star. And then it got worse. The light of the star, as you know, Betelgeuse, got fainter and fainter and fainter, reaching a minimum that's 3 times fainter than it normally is at the beginning of February. And as a matter of fact, this is historic. People first started making written records and observations of Betelgeuse back in 1840. Sir John Herschel in England started measuring it, and it has never been as faint as it was in February of 2020. So what happened? Well, our speculation is that what we found with Hubble, this big cloud moving out, moved further out in the atmosphere of the star. And it gets cooler as you move farther away from the surface of the star. And we believe that this hot material cooled down and then condensed and formed dust, like soot or something. So it's like a dark cloud in front of the southern part of the star. And that's why we believe that Betelgeuse appeared faint and even fainter. The cloud may have developed and then finally it dissipated, so that by the time April came around, Betelgeuse was back to normal.
Now, what would this sort of material being ejected from the star look like? Is this like very tiny submicron dust, like carbon or something, or is it bigger material? What's it like?
Well, there's different things. And when we're close to the surface of the star, we're above the photosphere of the star, the visible surface. It's a hot gas. So it's a very, very hot gas. And then as it moves out, it really goes into sort of grains. I mean, material like dust, like soot. And what it's made of is something that we're trying to calculate right now. We have many images of it taken through the late winter and early spring. And some of my colleagues are trying to model this using all the information we have about how it varied, what the color of it might be, and trying various models of various compositions to see if they can reproduce the observations that we see.
Betelgeuse is a noteworthy star because it's close and it's huge, therefore we can image its disk. Did we get any direct images of the disk of Betelgeuse while it was dimmed like this in the southern part of the star?
Yes, we did using an interferometric instrument on the telescopes in Chile that are run by the European Southern Observatory. It's an instrument called SPHERE, like a ball, sphere. And we could actually image the star, and this was put out on Valentine's Day, and you see the bright top of the star. It looks but the bottom is just very, very dim. And we could compare it to something we had taken earlier in the year, in January, when the star looked perfectly normal. It looked round, and maybe there was a bright spot in the north, and it looked perfectly, as I said, normal. But in December and subsequently, this cloud developed over the southern part of the star.
Now, the star, invisible light, obviously very much dim. In other areas of the spectrum, what did it do? I mean, was there sort of any infrared or ultraviolet or anything else that yielded?
That was the clue that we got from Hubble, which is an ultraviolet spectrum in the fall, in September through November. We had ultraviolet spectra from the Hubble Space Telescope. And that's what gave us the clue to this hot material that was moving out. We could see that it was moving out. We could see that it was very hot and it was very dense. We couldn't measure this from the ground because the spectrum that one measures on the ground generally is more of the surface of the star. It's not of the layers above the surface of the star. So we think that something happened during the summer. And you know, when you mentioned Betelgeuse is pulsating, well, you know, there's something very interesting. Not only was Betelgeuse moving out, the atmosphere, the surface was moving out from January through November or December of 2019, but at that time we believed there was a huge convective cell. We have imaged Betelgeuse previously, years ago, and we know that there are these very big convective cells. I mean, they take up maybe a quarter of the star, and they appear and they disappear. It's hot material on the surface that's boiling around and moving around like chocolate sauce. It's convecting and boiling around in on your stove. And we could see that by going to the ultraviolet region of the spectrum with the Hubble Space Telescope, we could probe these hot layers above the surface where we could see the material moving out.
Now, this convection that goes on at Betelgeuse is also, it's the reason it's not going to survive very much longer, in geologic terms, of course, timescales. But there's always a question. Yeah, Betelgeuse is going to go supernova eventually, 100,000 years, something like that. Or maybe tomorrow. Could this be an indicator that Betelgeuse is about to explode?
I know, you're not the first person who's thought about that. As a matter of fact, if you went to social media in February, I loved it. Somebody wrote, "My calculations show that the star is going to explode tonight." And then he wrote #hide. Now, I'm not sure where you hide exactly, under the table, under your desk, you know. The very interesting thing is we don't know how a supernova behaves right before it explodes. We don't know whether suddenly it gets fainter as the surface layers are collapsing in on the core, or whether it just suddenly gets brighter. The reason is that people don't have the resources to follow every star in the sky every night and then reconstruct and look back to see what happened with the supernova when a supernova occurs. Now, people do know maybe, 6 months before, a year before, 2 years before, how a star behaves. But if you really want to go hide under your desk because something's happening tonight, we don't know what to look for.
If the star did explode, we would see that pretty prominently, right?
Oh, yes. Some people even say you'll see it in the daytime and it will cast shadows. We shall see. I don't know if we will see in our lifetime, but it certainly would put a damper on nighttime astronomy because you'll have something that's brighter than the full moon, very obvious in the sky. And you realize, of course, that because of the fact that light takes time to travel from that star to us, that if it has exploded, it's already exploded and the message is on its way, okay? Because Betelgeuse is about 750 light years away. And so if you subtract, 750 from 2020, I think you get something back around 1300 AD. So maybe it already exploded. Who knows?
Sort of interesting. That about the time that someone was seeing the supernova that would eventually form M1, Crab Nebula, about that time Betelgeuse might have been exploding. Something poetic about that, but I think it would be really sad because number one, we'd lose Betelgeuse and Orion wouldn't look right anymore.
I know. Did you go out and look at it? Because it was strange.
I was shocked. Well, I've been an amateur astronomer for over 30 years, and I have never seen anything like that. I mean,
I
I've
know.
seen variable stars, but this was unbelievable,
Oh, no,
especially
I know. The whole constellation just looked wrong. I mean, it wasn't right at all.
right. And it was, I mean, I'm looking at it, and I mean, stars that normally should be far dimmer than Betelgeuse became the prominent stars of the constellation briefly as Betelgeuse dipped. Now we're just now getting to where we can study Betelgeuse again, and it's coming out of the sunlight, and at least from space anyway. And it looks like it's dimming again. Any thoughts?
Well, it is. First of all, we did see Betelgeuse when it was close to the sun, and let me tell you how we did that. It turns out that the Earth, of course, where our position was looking at Betelgeuse, it was too close to the sun. It was behind the sun or near the sun's glare. You couldn't see it. However, we have a satellite that's in the Earth's orbit, but it is behind the Earth in its orbit by about 2.5 months. So what this means is that when we could not see it from the Earth in June, this satellite didn't think it was June at all. It thought it was mid-March and had no problem. So we were delighted to find that the satellite folks, this is a satellite called Stereo, which is trailing the Earth right now in its orbit. And we used a camera on board this satellite Stereo in order to take several images of the field. And we did this in June, July, and August. And we could see that it was getting fainter. And it's too soon for it to be getting fainter. So we're not quite sure what's happening, whether we're getting another episode of dust or whether it's just teasing us and it's going to get brighter again. We don't know.
Could it be like an aftershock from something related to the original event?
Well, you bring up an interesting point, and we're thinking about this now because, you know, when we observe the sun, which of course is a smaller star, and phenomena are similar in some ways, but also different in other ways, we find from the sun that there are these phenomena called coronal mass ejections, where after the magnetic field reconfigures, material is suddenly ejected from the sun. This is a very fast process. It happens over, minutes to hours. But then it leaves behind sort of an empty space, a place where the temperature may be lower and the density may be lower because all this material has suddenly been ejected from the sun. And that leads us to think what happened with Betelgeuse, because in Betelgeuse, this area was much, much larger than the equivalent of a coronal mass ejection on the sun. I mean, remember that Betelgeuse has a size, it's about 1,000 times bigger than the sun. And this occupied about a quarter of the size, of the diameter of the area of Betelgeuse. So this is really, really, really big. We're talking 1,000 times the size of the sun. And all of a sudden, the material vanished. And we don't know what happened. We're working on this. This requires more than hand waving, I think. And so we're trying to think what would happen. In other words, perhaps there really is a very low density region, or a region that's much cooler and at the left behind because all this material vanished. But it's an interesting and exciting problem to think about.
Now, has anything like this ever been seen with any of the other similar stars to Betelgeuse, these red supergiant stars?
Not with red supergiants. However, there's a flavor of star called our Corona Borealis stars. Now, these stars are also supergiants, but they're warmer. They're much warmer. They're warmer than the sun, have a higher temperature than the sun. And they are known to eject a lot of material that turns into carbon dust very, very quickly. And it causes these stars to lose 3 and 4 and 5 magnitudes. I mean, we're talking factors of 100, not factors of 3. And this can happen within days. So we see other stars, not the red supergiants, but these are more like yellow supergiants that do eject a lot of material that substantially changes their brightness and varies. So we know the phenomenon exists on a much larger scale than what we've seen with Betelgeuse. Now, another thing that's interesting is where this material came from the star, because it looks to us from Hubble as if it came from the southeast part of the star. And from studies with Hubble and with ALMA, which is the radio telescopes in Chile, we know the rotation. We know the axis of rotation of Betelgeuse. We know how the star itself is rotating. And we know that the axis and the pole emerges in the southwest of the star, not the southeast of the star. And we suspected, and theories frequently suggest, that maybe material should only come from the polar, from the rotation axis. And we see jets from very young stars, and the jet material is ejected along the axis of rotation of the star. But what we observed in Betelgeuse is different. In other words, it seems to be coming from the southeast, from a different side of the star, suggesting that stars can lose substantial amounts of material from anywhere. It's not so simple. So this has introduced sort of another wrinkle into how we understand stars, their evolution, the mass loss, and the structure and the character of the winds that they're enduring.
One has to also note the creation of carbon, which is very important to life.
Of course. Well, stars make everything, I mean, it's not only carbon, but iron and calcium and sodium. I mean, everything that we know and love to make life and us.
We are star stuff.
Star stuff, yep.
Any possibilities of, I know Betelgeuse is not that old, but is there any possibilities of exoplanets around it, or would they have just been gobbled up?
Well, if they were within the orbit of Jupiter, you realize Betelgeuse, if you put it at the center of the solar system, the surface would extend out to Jupiter, okay? If there were any planets within, they long gone. As a matter of fact, that brings up another puzzle about the star. It seems to be rotating more rapidly than we think. We have some idea of, as stars are formed and they start out life on the main sequence, and then they evolve and they become red giants and they swell up. We have an idea of how the rotation should change, and they might start spinning very rapidly when they're born, and then they slow down. Well, Betelgeuse is spinning more rapidly than we expect. And actually, we had suggested some years ago when we found this, we said, well, maybe it's swallowed planets. We were thinking of something that would add angular momentum to the star. And lately, there have been some simulations where people are supposing that Betelgeuse started as a binary star. And maybe this star swallowed up its companion. And that's what makes it spin so rapidly, or more rapidly than expected. And certainly if planets got in the way, they are long gone, but it's not clear that they would add enough angular momentum to the star to spin it up to what we see.
Now that brings up something interesting, is that, Betelgeuse being as enormous as it is, covering the entire orbit of Jupiter, that ejection that caused the dimming was enormous. Would have taken up a large chunk of our solar system, or at least our inner solar system.
That is correct. Watch out. Yes.
Yeah, you gotta, first, just the titanic scale of such an event. Imagine if you were up close.
I know. Well, it's also interesting because one of the current issues in astronomy today is exoplanets and what is the environment that an exoplanet lives in. Because if an exoplanet is in the middle of a very brisk, rapid, massive stellar wind, this is going to blow the atmosphere of the planet away. There's going to be no hope to have an atmosphere such as we have on Earth. So we're very interested in knowing where stars lose material and how they lose material. I mean, if, for instance, all the material is coming out at the poles and the exoplanets are in the equator, just as similar to what we see in our solar system, then there might not be a problem. But if the star can produce material and send off a wind in a bursting outflow from anywhere on the star, well, watch out, because it could certainly affect what's happening to the atmosphere of an exoplanet. And we know that some of them have atmospheres. I mean, that we've been able to measure and see that there are evaporating atmospheres on some of these exoplanets. So it's all tied together. I mean, we might think we're studying how stars evolve, but it has many implications throughout astronomy and astrophysics.
So it has a bearing on, like, as you mentioned, like evaporating superjupiters and things like that, where you see a tail coming off of the planet and eventually what's left,
Oh, yes. No, they have. They've seen expanding helium atmospheres using some very good diagnostics in the near infrared. And then what happens is as the exoplanet passes in front of its host star, you take spectra very, very rapidly. And this is back to spectra again, which when you take the light and break it up into colors, you can find out all sorts of wonderful things about what's happening at a distance. And so then they actually can see the evaporation of the helium atmosphere from the atmosphere of the exoplanet.
This, of course, weighs into a debate that's heating up lately about looking for technosignatures around exoplanets.
Oh.
Gases and things that shouldn't be there, like CFCs and such.
I know. There's also room for lots of imagination, I must tell you.
Well, imagination, but at the same time, if you see CFCs, it's I mean, there's not much of a way to make that other than a civilization.
We'll see. Well, didn't Frank Drake, he sent out signals from Arecibo years ago and beamed them towards M31, I believe, with all sorts of coded signals of DNA and hydrogen and who knows what else. And they're still listening. We haven't had any answers. Someone was saying what they're really hearing is howdy doody from our 1950s television sets or something.
Well, with the Arecibo signal, I worry that that's someone else's wow signal because we didn't repeat it. And that some alien civilization out there thousands of years in the future will intercept it and go, well, we need to study that. Oh, it's not there anymore.
Well, we'll see.
So what do you expect for Betelgeuse this coming year? I mean, it's surprising already. So do you get a sense that this is sort of...
But on Monday night, this is Friday, in 3 more days, we're going back to it with Hubble. So I will find out what I expect. I don't know. It may be with the stereo observations, we could see that it was getting dimmer, and this is before we expected it to get dimmer. So we had 5 measures and it was dimmer, and then the last 2 seemed to be similar, as if it had stopped getting dimmer again. But it's still fainter than average. In other words, usually it's about, half a magnitude, 0.5 or something. It was down around 0.8. And it may have stopped. We're not sure yet, because a lot of the ground-based observations are still very, very difficult to make. We lost it with stereo. It moved too close to the sun for stereo to take an image. But the ground is beginning to have access to it. And hopefully in the next, come back in a month, and we'll have some answers for you.
Now, regarding the spectra of Betelgeuse, under normal circumstances with the star's big convecting cells, do you see changes in composition? I mean, does it evolve? Do you see certain elements dredging up as opposed to others?
No.
Really?
No, the time scale's too short for us to see that. We see mainly temperature changes, density changes, and changes in motion. In other words, we could watch different parts of the star moving to the east and then to the west 2 months later and things like that, watching the sort of swirling motions in the atmosphere. But we do not see any changes in the chemical abundance. That's actually very, very hard to measure because you can have changes in physical conditions, changes in temperature, and changes in density, which might create a change in the emission, but it's really not caused by an absolute abundance change. It's caused by a change in the physical conditions that change the excitation and ionization of the atoms and ions that are in the atmosphere.
Amazing. Now, Doctor, I have one other question for you before we finish up. When we were preparing for this interview, we came across how you started your career on a coin flip. Tell us about that.
Well, I went to a liberal arts college where one had to have distribution requirements. This is Wellesley College, an amazingly wonderful, powerful women's college in Massachusetts. And I remember sitting the summer before my freshman year, and you had to elect your courses for the year. And the first thing a student wants to do is let's get rid of all the requirements, right? We know we have to take certain things, so let's just, buckle up and do it right now. And one of the requirements was a laboratory science. And you had to have a year of a laboratory science, meaning you had to, get your hands dirty and wet and build things or explode things or look at the stars. And I remember looking at the choices, and they were the typical choices. There was physics and chemistry and biology. And I always went to college with the idea, I was going with the idea that I wanted to learn new things that I knew nothing about, because that's why you go to college. And I looked at all these laboratory courses and I thought, well, I'd had 4 years of science in high school. So I'd had a little physics, a little chemistry, a little biology. And I thought, well, there's two things that I really know nothing about: geology and astronomy. I mean, we just didn't have that in high school. I went to a public high school in Massachusetts, and we didn't have geology and astronomy. And I didn't know how to decide, and I flipped a coin. And it came up, I don't know, heads astronomy. And then it turned out that I really loved it because it was real. In other words, you could catch the light from a star, or you knew that there were galaxies out there, and it was real. And it was just a perfect match. So I was a physics major and an astronomy major, and it's worked out well. I still have an adventure spirit to find out what's going on in our universe.
I wish you great luck in your continuing study of Betelgeuse, and it's going to be interesting to see what that star does this year.
That's right. Well, as I said, come back in a month and we'll tell you what's happening.
It's like the Mark Twain's old adage about the weather in Missouri: if you don't like it, stay a bit.
That's right.
Thank you, Doctor, and I hope you'll come back and see us sometime.
I'll do that. Thank you so much. Okay,
Yep.
Bye-bye.
Bye. What's that noise?
Oh, that's just the new and improved John Bot Mark II.
Yeah, John Bot Mark II, like we needed another one.
I had some funds left over from last quarter, so I put them to comical use.
You had extra funds and didn't tell me? I went without beard wax for all of August.
About that, John.
Hello, I am John Bot. Anna is great. John is not. The possum is okay.
What? He doesn't have a beard.
I know. I ran out of money.
Well, they are rather expensive now that you say that.
Yes, they are. We've been footing your beard bill for the past 3 years.
Problem solved. I will use the possum as my beard.
I don't think he's going to like that.
Ow, my beard. Ow, ow, ow.
Well, that's the end of John Bot number 2. And on that note, join us next week with a chat with the director of the Vatican Observatory, Brother Guy Consolmagno. Yes, they do astronomical research. See you then.